All right, welcome to the first VRF Tech Talk podcast. My name's Donald Felice. I've been working on VRF for about 8 years, joined by Steve Cook. He'll give you a little background on himself.
My name is Steve Cook. I've been in the VRF industry for about 8 years. HVAC altogether about 16, 17. But I work for a equipment manufacturer, and I'm very passionate about just VRF technology in general.
Yeah, so it's brought a common group of us together, and I think this podcast has been a long time in the making. That there's just nothing else out there currently. So one of the things that we want to cover, or one of the fundamentals of this podcast, is some of us work for manufacturers, some of us work for manufacturers' reps. All of us are passionate about VRF in general, or variable refrigerant volume technology, and I just want to state that everything that you're hearing henceforward is the opinion of the person that states it. It no way reflects on their employer or anything like that. So
right, yeah,
the first episode,
I'll echo to that. I work for a manufacturer as well, and these. Well, I'll try to align as much with that respective manufacturer as possible. I'd say every opinion I have is my own experience and my opinion directly.
Yeah, so everything that I'm going to say is based on 8 years of experience working in the field, working with contractors, and just really getting to know this technology inside and out. So without further ado, let's jump into a little bit of the basic stuff. So to boil down what VRF is, I think we start with the fundamental of what refrigeration is in terms of air conditioning. It's not completely different. We still have evaporators, we still have condensers, we still have a compressor, we still have some kind of metering device. The way that we differ now, right, is we're using electronic expansion valves. We're using a variable speed compressor, right? We're allowing that compressor to change its speed to add more volume or less volume, right? We're changing the flow of the refrigerant. But the basics are still there, right? We're still condensing, we're still evaporating, we're still moving heat.
Right, exactly. There's no breaking the laws of any thermodynamics with VRF equipment. It's in the simplest form. It's still just as simple as the system you learned on in trade school, like you mentioned, the compressor, the evaporator coil, the condensing coil, the metering device. The condensing coil, that doesn't change. There's, for the most part, unless it's in heat mode, but there's more heat exchangers and there's more evaporators. Your compressor's still the heart, but nothing, it's just more of these components, and it's all about flow.
Yeah, so we could say that VRF technology, or VRF, is air conditioning at a macro level, right? So we have multiple different zones or multiple different areas or heads or whatever you want to call it, fan coils. Everybody has a different term for it. But, the one thing that we're not doing is we're not centralizing airflow, right? We're prioritizing refrigerant flow to get to these different zones so that ultimate comfort cooling or comfort heating is achievable.
Absolutely.
So, like we were saying, is the refrigeration technology is still the same, right? We're leaving the compressor as a high pressure hot gas, right? We're going into, depending on what mode we're going into, we're either going through the condensing coils outside, or we're sending that hot gas directly inside for heat mode, just like a regular heat pump would do. What happens after that is kind of what makes this VRF, right? This is what the technology really is driven on, is being able to use that refrigerant that's already been pumped inside to do something other than the one thing that it was made for, right? So we can do heating, cooling simultaneously on the same system with the same compressor. So in the terms of, a Daikin VRV heat recovery system, we only have one compressor at the outdoor unit, and we're doing exactly what it's called. We're recovering energy to use in other zones.
Exactly. It always goes from, if it's in a mixed mode, it always starts off as it feeds the heat, whatever zone needs heat first. It starts there, then works its way down to cooling. So you can't start with cooling, feed a zone that's calling for cooling refrigerant first, then that refrigerant go to a zone that's calling for heating. It can't. That physically cannot happen. It starts with, if you have a zone calling, zone 1's calling for heat, zone 2 is calling for cooling. The refrigerant will flow to zone 1 first, take care of that, subcool the liquid, and then it'll flow over to zone 2 that's calling for cooling, and it'll use that subcooled liquid as it would in a normal DX condition. Then it'll meter it off from there, boil it, and then go back to the outer unit. That's just repeated dozens and dozens of times throughout the system if it's in a mixed mode. Really depends on if it's majority cooling or heating. You'll never have the unicorn mode, as we call it, or 50-50.
50-50, right.
Yeah, that one. Yeah.
A way to think about that is when you check into a hotel room, right? Steve, you travel a lot, so when you check into a hotel room, what's the first thing you do with the thermostat in that space, right?
Oh man, I crank that bad boy down.
Right. So same principles apply with VRF. We're based on the indoor load is where all our refrigerant's gonna go, right? So like you're saying, it's never, can't say never, but it's usually not a perfect 50-50 split of heating and cooling on a system.
Oh, absolutely. And it's because of people like me that that 50-50 doesn't exist. I'll check. I mean, I was just driving last week, and it doesn't matter how cold it is outside. It could be in the 30s, and I want my room to be like mid-60s. It's kind of ridiculous, but that's the only place I can do it. I can't do it here at home.
No.
Too many people complaining about it.
So the next thing I think we want to talk about briefly is the difference between what commonly people think of 2-pipe and 3-pipe. So in the VRF industry, we have some designations of 2-pipe systems and 3-pipe systems, and it changes per manufacturer what 2-pipe and 3-pipe means, but typically a 2-pipe system is going to be a heat pump, right? It's going to be the same technology or the same concept as just a straight heat pump like you would have in your house, where 3-pipe adds the addition of something called a branch controller, or branch selector, or some kind of branch provider box that allows for that simultaneous heating and cooling to the indoor zones. Steve, with a background in Mitsubishi, can speak on that 2-pipe per manufacturer side, right? Because some manufacturers are able to achieve heat recovery with still just 2 pipes.
Right. So it's the same sort of principle. It just a 3-pipe system. It obviously has 3 pipes connecting the outer unit to the switch box or the heat recovery unit, whatever you might want to call it. The outer unit in those cases generate the hot gas. So the hot gas is right off the compressor and it's sent out. And then you have a liquid line, and then you have a suction line returning back. So in the case of a 2-pipe system like Mitsubishi's, in hot gas is sent, it goes through the condensing coil and cooling mode, but most of the subcooling in the system happens at the branch circuit box. Your hot gas essentially would be sent out from the compressor, and depending on the mode, let's say you're calling for mostly cooling, 100% cooling, your liquid is going to enter a liquid gas separator. Your liquid's going to go out the bottom. Your hot gas is going to go at the top, and it's going to sort it out from there on. And then from that point on in the system, it is a 3-pipe. So if there's another branch box or switch box, wherever you want, the term you want to use there, from that main BC and Mitsubishi's world to the next one, it will be a 3-pipe. It'll be your hot gas, your liquid, and your suction. Basically, what they're doing is they're extending what's happening in the 3-pipe system outdoors. They're doing part of that inside.
Now, with that said, we're part of that process of heat recovery is done indoors rather than running that full third pipe back up to the outdoor unit. Is there any differences between, say, a Daikin branch controller and a Mitsubishi branch provider or branch controller box that is there anything to account for?
There's a lot more complexities in the Mitsubishi box than there is in any 3-pipe brands, and because of that, there's a lot more piping, there's a lot more mechanisms, and there's a lot more refrigerant charge based off just that box itself. Whereas Daikin, LG, Samsung, those boxes literally just route refrigerant. Nothing really happens there for the most part. As far as refrigerant change of phase, there are some boxes. I know Daikin does have an EEV in there to where it can subcool in certain modes, but for the most part, while no change of phase really happens, it's just routing. The Mitsubishi has a change of phase, so there's a lot of bits and pieces of moving parts in there. So it is kind of difficult to go from one to the other. That learning curve is pretty difficult to get over once you're used to the Mitsubishi system, and it's hard to take that theory and apply it on the other side on 3-pipes, especially if you've been working with it for so long.
Right. So with that said, you said that at the Mitsubishi boxes there is definitely a change of phase going on. In the Daikin world, the boxes that we have are jam-packed with foam. Even if there was a change of phase, there's no chance that it's going to condensate internally. The Mitsubishi boxes, though, because they can change phase internally, right? If you have one box is in cooling, one box is in heating, that box that's in cooling is definitely going to have some condensation. That's one of the major differences between a manufacturer is that condensation needs to be managed on both indoor and the branch controllers, right?
Yeah, correct. Mitsubishi does generate condensation on the branch, the BC controller. However, it's very little. You're really only going to see it on first startup when the system is basically at ambient temperature, and then you have an inrush of subcooled liquid going through that box. You'll see it then. After that, you really won't see much. That's pretty well true for the most part. You can honestly, after about a week of it running, you won't see much condensate coming off of it at all. And the Daikin in a certain mode, like a parallel mode, it does have a heat exchanger to provide a more subcooled liquid feeding the unit's calling for cooling. But like you said, they're all covered in foam, so there's really no chance of it producing condensation. So their condensation management is pretty well solid as far as not requiring any of that. And there's been a lot of people that complain about the fourth pipe effectively is what I've heard.
Right.
Or the third pipe, I should say. People will say it does have 3 pipes, the Mitsubishi's BC controller, and that third pipe being the condensate drain line.
Right, and you touched on it briefly, is that the Daikin boxes do have a internal tube-and-tube heat exchanger for some subcooling, but I mean, the subcooling coming off of that is ideally so minimal that it's not going to make or break anything, right? We're not going to see, oh my God, it's subcooling our liquid temperature's coming down 25 degrees. No, it's not doing that much.
Yeah, it's not doing much. And it's so encased in foam that it won't do anything.
Right. But that's a good topic to, I guess, transfer into is expansion valves, like electronic expansion valves, right? People might have heard us talk about EEVs, or they might see EEVs. It's becoming more prevalent on, some of the residential split systems too, right? Like Bosch has a inverter system that uses an internal or inside EEV on their heat exchanger on the indoor unit. But EEVs to VRF, I mean, they're literally everywhere. The outdoor unit has upwards of 5. The indoor unit has 1. The branch selectors on Daikin have 3 per branch selector. So there's literally EEVs everywhere, or electronic expansion valves. And what an electronic expansion valve is it's almost a direct analog to a TXV or thermal expansion valve. But instead of a sensing bulb, we're using a thermistor. We're using something electronic to give a computer feedback rather than a direct coupled bulb for the TXV that's allowing that to open and close based on temperature and gas pressure. The EEVs are open and closed based on the computer algorithm and temperatures and pressure inputs from system-wide.
Right, and that is exactly kind of the reason why VRF works the way it does, is because the system the whole system can control itself. If it had TXVs, you can't control the position of a valve at all. I mean, it'll eventually open to the direction you want, but you're not really controlling it. So that's how, regardless of the mode, if you switch from heating and cooling, if you have a TXV and that one indoor unit went from cooling to heating, that sensing bulb would stay closed so long to where you'd be building head pressure on that coil before the valve finally opened up. So there's no way to really control the system with any other metering device except for EEVs.
Right. Our compressors are variable to a point, but you brought up a good point, right? If we didn't have some way of metering refrigerant kind of like an on-demand state, our head pressure is going to climb, right? I mean, like we were talking about at the beginning of this, is that the system is no different than any other air conditioning system out there. We've just has a little bit more specialty pieces to it. Right? We've talked about our expansion valves. We've talked about variable speed compressor. We'll talk about inverters later on. But where I think we should lead this conversation next is the use of four-way valves, or the use of changeover valves in a system to basically make the evaporator the condenser and make the condenser the evaporators, right? That's how we get that simultaneous or that variable refrigerant technology, right? Is we use four-way valves just like a regular heat pump would be to shift the flow of refrigerant based on the demand of the indoor.
Right.
And Steve, you said something, that I want to touch base on is like the computers or the PCBs, the boards in these units reference, the system. Everything is communicating back to everything. And I think that's really important to note that it's I'm looking for a better word than system. It's a ecosystem, right? Like everything has feedback to everything. And that's one of the things that kind of scares some of the new techs is like, where do you even start? All right, because everything has an input to everything else. Where do you even start? So that's a good leeway into what are some of the other components in a VRF system that aren't exactly what you would find in your split at home.
Yeah, so you're, and that's the kind of the neat thing about this equipment is there's a lot of components that carry over from unitary to this equipment. Likely are the four-way valves there's a good chance they're likely made from the same manufacturer if it's on a unitary compared to a VRF. Likewise with the EVs, most of them are manufactured by Fujikoki, and those many different brands use them. So even unitaries, like the train, unitary equipment controlled by EV uses those metering devices. So it's nothing. The good thing of that is that, you know, a lot of techs are getting exposed to it, whether they like it or not. Because if you think you can not deal with inverter-driven equipment in this industry,
good luck.
Good luck with that. I mean, I'm not sure what industry or what market rather you'd find work in 10, 15 years that you won't see an inverter-driven piece of machinery. But as far as components that, those are the components that are shared. But with the complexities of the system, there's a lot of different components there, but they're not there just for the sake of making it more difficult. You get on some of these forums and some of these groups, and you see these guys think it's overcomplicated junk. When these things are designed and engineered, they're not sitting in a room thinking, how can we get this as complicated as possible? Right. These machines are as simple as they can possibly be to do the task that we ask them to do. And right. So there are some complexities to them.
Yeah, definitely. One of the most common things I see from the field, and let me back up, is I work for a equipment sales rep, and we rep Daikin VRV, and what I do for that company is lead a tech support department, strictly working on Daikin VRV. So I've seen this stuff day in, day out for better part of 8 years, and there's in that time there's been 1, 2, 3, 4, 5 generations of equipment, and every year it's like, oh, what new did they add, or what do I got to learn now? And then but you boil it down, and it's still the same principle. It's just got a new pretty paint coat.
Right. Yeah.
So to that point, right? Like when I approach a job site with technicians that are a little bit greener with the VRF technology, they open up the machine for the first time, and there's tons of copper, and there's valves everywhere, and there's big compressors in there, and the first thing I tell them is to just slow down, back up, and just think about this as an air conditioner rather than something else. There's a lot of pipe in there, but it all boils down to the same principle, right? We want to cool a space, we want to heat a space. And how we're doing that now is, like we touched on in the beginning, is we're spreading out, right? We're allowing for a larger network of indoor units rather than, a packaged rooftop or a boxcar with tons of ductwork. We're decentralizing the air conditioning system with one common compressor. And that kind of leads into an inverter talk, right? Like what is an inverter, right? So inverters are almost everywhere at this point in life, right? You have refrigerators, washer machines, water heaters, right? Now we have air conditioning systems that are inverter driven. A lot of technicians, when they walk into, or at least my experience, when they walk up to a VRV, piece of equipment, oh man, I don't know how the inverter works. And then I ask them, I was like, have you ever worked on a frequency drive, a VFD? Like, yeah, I was starting them up all the time. It's like, okay, well, it's no different, right? We still have an input voltage that is being chopped up and then sent back out to a rotating device.
Right. Yeah, I mean, it's really, and that's one of the great things about it is, since, if you talk about VFDs, a lot of techs seem to really enjoy the idea of a VFD, but they don't like the idea of inverter-driven compressors for some reason, even though it's the same thing. And it's not difficult. I mean, it really just takes line voltage, converts it, then smooths it, then inverts it back to a simulated AC, and it's all the same. It's not like any company's doing any different. They'll take the inverter circuit, will convert it back to DC into a 3-phase AC using IGBTs, insulated gate bipolar transistors, to drive the compressor. And those opening and closing at different frequencies or different speeds is what creates our different frequency and voltage, or variable voltage. And those are all monitored by current output, basically, to the compressor or to the motor, whatever it might be. And so once you understand that bit, it's beautifully simple. You can take that, a Yaskawa drive, and you can, what you learn there, you can apply it to any inverter-driven equipment.
Right.
That's a great thing about.
Yeah, I mean, I think something important to note there is when we're talking about an inverter compressor, right? Where the standard train of thought here is that 60 hertz, right? That's what my compressor is going to run at. That's the ultimate speed that it's going to be. And let's back up one step, right? When somebody says something is 60 hertz, right? We know what 60 is. It's a number. We know what hertz is. It's a measurement of time, right? So cycles per second, right? So 60 hertz means it's cycling 60 times per second. When we get into inverter technology, right? Like, I'm just looking at a chart here for a Daikin piece of equipment. The compressors in that can step to 399 hertz. So we're going well above and beyond the 60 hertz, coming out of your socket, your wall plug.
It's like a Dremel.
Yeah, we're jamming this thing up to nearly 400 hertz, and that is the essence of what VRF is, right? Where we have the ability, due to inverters or frequency drives, to speed up, slow down the compressors to manage the indoor load, right? So we're not banging on a compressor. It runs for 15 minutes. We overcool the space by 3 degrees. It turns off. We wait for it to heat up in that space by another 3 degrees, and then we bang it back on. So one of the most common things that I hear with people that are getting an inverter piece of equipment, for the first time in their life, is it never shuts off, right? And ultimately, that's the goal, is if we can maintain that compressor running at, let's just pick a number. Let's pick 60 hertz as the low end, and then 170 as the high end. If we can maintain somewhere in there, in that range, and the comfort doesn't drift away from plus or minus a degree or two from set point, then there's no need to really shut that compressor off, right? And I think the misconception is we're using more energy to keep that compressor running, where we're missing something is that inrush of turning on a standard compressor, going across the line contactor. That's where the energy savings is lost.
Yeah, I would agree. And there's a lot of it's amazing how confused guys will get this. Even good guys in the field. I had an experience where there was a contractor installing some of our equipment last week, and this guy is a Daikin Pro contractor, so he Comfort Pro. That's it. He knows the process. He knows the equipment, I should say. But then when you hear him talk, it's almost like he was. Yeah, it was wild. It's, this guy was pushing Daikin. He was pushing Daikin Fits, VRV, the Daikin Life product line. I'm not too familiar with the Daikin product line, so I might have butchered some of that. But then when it got to, he was wanting to know how to charge this machine, and it was a inverter-driven piece of equipment. He was saying he wants to know what the max hertz are, and he said, it's probably 60 hertz. And I was like, why on earth would it be 60? Like, what's the point of having an inverter-driven equipment if 60s are max?
Right.
And so he was trying to charge it based on full load, and he wanted to. Some of the stuff he was trying to figure out, trying to understand was, I knew the guy was smarter than this, and it kind of had to take him to slow down a bit and kind of smell the roses. It's almost like the old the old unitary version of this guy was coming out, and
I was just gonna say is like it might be. It's just a learning curve, right? Like it's not a standard piece of equipment.
And it's not. And that's the part of it is, as similar as a lot of them are, there still is some training that needs to be done, respective training to each brand, and I think you and I and everyone would encourage as much training as possible, so you don't
absolutely
you don't have any questions, you don't have any doubts. This way, you don't. I mean, you do not. I mean, I don't know how many times I've heard this, where guys will say, if it's inverter-driven equipment, you have to call tech support because you just don't know what it's doing. It's like that's the most. It's like that is the biggest lie. Like you can certainly understand what it's doing, and you do not have to call tech support every time.
There might be easier ways of getting that information, but let's be honest, subcooling is still subcooling, superheat still superheat, and this is still an air conditioner.
Yeah, it still exists.
That brings a question that I have. So you've been HVAC for 16 years, but in the last 8 you've been doing strictly VRF. What was it? I mean, could you give yourself a parallel to that gentleman that was installing that equipment 8 years ago and say like, you were in his shoes at once, right?
I was in his shoes once, but it was kind of interesting. Part of it is, I'm part of a new manufacturer, so I feel like he was trying to be as critical as possible to our equipment, and he was very quick to want to call it junk. But after it was installed, after he got up and running, he was very impressed with it, and he said he's actually wanted one for his house as well, and that is a true story.
That's awesome.
But it's what's interesting is, I kind of dove, feet first into this. I did a lot of what pulled me into this world was I was at a very large mechanical contractor, and we would install and start up VRF all the time. We were new construction, so we did a lot of commercial, industrial jobs, and everything was spec. So it's not like we were loyal to one brand. But I would start up LG, Panasonic. I did a lot of Panasonic, oddly enough, and Mitsubishi and some Daikin, and nobody wanted to work on it. And that kind of mindset is what kind of led me into this world. Is if no one at my mechanical contractor shop wanted to touch it, what's it like around the rest of the world or the rest of the country? And it was the same. No one really wanted to touch it, and you could tell that then it was kind of pixie dust and could be the future. And a lot of people didn't like it. Now it definitely is the future. There's no question about it. And people are just going to have to get used to it. But as far as relating to him and his point of view, I think it has a lot to do with our experiences and how we see things, how we deal with things, and how we always manage our service calls. His experience is more than mine when I jumped into it. So that's why I think it was kind of an odd case for him, but there were so many install issues this gentleman had, and I can't blame him too much because we had a team of like 20 people there kind of watching him, and then he was also being recorded by marketing. So it's like, this was a lot of like, ordinarily that would be like, you just be like, man, that's not really not the best install, but given the circumstance, he had the factory there watching him. He had marketing recording him with like a 4K, watching sweat bead off his face. I give him that benefit, but it reminded me of a saying I always love is, if you think the problem's out there, that very thought is the problem, and that's kind of what he was thinking. He kept saying, "This is not right. This is wrong," and then he realized, oh, he's wired it wrong, or there's a leak, and a bunch of other things. And once he kind of humbled himself and realized and wanted to learn, that's when it clicked, and that's when he actually began to really enjoy the equipment and understand it.
Yeah, I think you touched on something very important there. Is like there's a willingness that a technician needs to have, that right? You're not going to be able to call tech support every single time you have a problem, but there's also demand for good technicians, but that demand is, dwindling as more technicians are hungry for this, right? Like you said, that you jumped in feet first because nobody else wanted to. And, I deal with, 20, 30 contractors a day. And out of those 20, 30 contractors, there's probably 10 to 15 of them that are in that same scenario, right? Like they see that there's a future here with this technology, and they want to learn as much as they possibly can, right? To the point to where, I'm humbled by the guys that are going out and doing this day in, day out. And they're teaching me things, right? And I've been working on one brand of equipment for 8 years, and I have a guy that's been working on this stuff for 2 years teaching me something. And that's awesome because he has the drive, or they have the drive to want to learn a new technology that has and still is taking this market by storm.
Yeah. I mean, it's all about it is a lot to do with mindset. There's guys that you see that, we're smart, they're sharp, and they'll get it. And there's guys that, they just, and the weird thing is, there's a lot of older guys, and they're pushing retirement, and I understand their point of view. They want to retire and get out before they have to learn anything new. That totally makes sense. I wouldn't want to do that either. But there's a lot of young guys that really dislike this, and it's like that's to me that's so wild. Like right out of trade school, I can understand it. With me or yourself, I went out of trade school, almost 20 years ago, and the inverter-driven equipment was unheard of then. But now it's like, I don't know what they're teaching in these trade schools, but so many guys have no clue how to work on it. And because of that, they get this ignorance against it and this unwillingness to learn. If they can't look at it and see the capacitor is blown, they don't want to touch it. And just that mindset is like, if you can diagnose this equipment, how much more valuable you are.
Oh yeah, you write your own paycheck at that point. So we have some, I wouldn't call them pretty strong, but we have a lot of the contractors that I deal with on a daily basis that are actual instructors in union halls, and we're seeing a big push lately for union halls to get in manufacturer equipment. So get Daikin, get Mitsubishi, get Hitachi is another big one in our area, Samsung. They get this equipment in their trade halls, and it's night and day difference between a technician that's been through the hall that has this opportunity versus somebody that doesn't. And I think that definitely clears up some of that murky, scary area when you first open this unit and you see, hundreds of feet of copper pipe where, these technicians turning out that have dealt with this are less afraid of it, and they're eager to learn. They're eager to jump in. Now you touched on calling tech support, right? Like, that's what I do for a living, is I am in-house tech support. So I hope I never get obsoleted, but I enjoy working on this stuff. I enjoy the challenge of VRV, the challenge of finding the needle in the haystack, so be it on troubleshooting and things like that. My story is different. I was an auto tech before I started working on this, so I've always been mechanically inclined, but air conditioning, I started doing air conditioning 8 years ago, so I'm way farther behind than most people in this trade of my age based on just pure experience. But I've embraced this VRF technology, and just that's all I've wanted to work on.
And see, that's great. That's the way. I feel like that's how it should be. And a lot of guys knock unions. One thing I do like the unions, or rather the union. There's really, for the most part, one that for the HVAC trade. But there's the way they administer training and the culture they create within their union, within their hall, for further education. And I don't know where this mentality came from. You learn how to, you go through trade school and you one and done. I can safely say everything I learned in trade school almost 20 years ago is nearly useless by now.
Yeah,
I can't imagine. I can't think of a time I actually recalled on any of that information outside like the first year, and even the first year it was. I realized it was useless then.
Yeah, how do you troubleshoot coal-fired boiler and the pneumatic thermostat.
Exactly. And the fun thing was, it sounds ridiculous, but with some of the stuff they didn't instruct on, like they were big on unitary gas furnaces and basic air conditioners in trade school. And so that was 2005 is when 2004, 2005 is when I attended the trade school. And so they already, the industry had already moved on from, standing pilot furnaces or even just basic electric air handlers. And so as basic as those components are, I dislike those so much because I was never really trained on them. I didn't know how to work. Even though I could diagnose and troubleshoot a natural gas furnace, I had a hard time with just basic standing pilot. And as simple as it was, that was kind of like the paradigm shift it took for me to realize this stuff is more simple. I mean, you look at the wiring diagram, there's nothing to it. And it kind of got down to someone telling me, a foreign boss telling me I need help reading a diagram. And, at that point, that's when I realized, I was programmed by this trade school to just fix, 13C air conditioners and gas furnaces. And that's what these local companies wanted. And if it wasn't within that scope, if it was anything older, they wanted you to sell. So they didn't want you to fix it. So I was kind of programmed and tuned to do just that. And I realized I don't want to sell anything. That's not my job. That's not me. That's not what I do. And I still maintain that. Like I've kind of redeveloped my I guess what I want to do, but I don't do sales. I've never done sales, but I make sure my sales team can sell more than one.
I mean, what you said just a minute ago about when I was an auto tech, I had a master mechanic teach me something. I was really frustrated one day working on something, and he looked at me and he told me to put the tools down, and he told me, look in the parts tray. What's in there? I was like, it's all the nuts and bolts. I was like, okay. All he told me was, it's still just nuts and bolts. Put it back together. Right? So I use that in a parallel when I'm doing a training. I tell these guys, it's still refrigerant. It's still just copper. Put it together.
Yeah.
You could see, the guys that really get it, you could see their eyes open up and go, oh man, yeah, you're right. It's still just an air conditioner. And
a lot of that has to do with ownership of training. I think if you just go there to just sit down and, especially if you travel to train, if you go there just for the hotel or get some, some free beers, whatever, on company free dime, food, you're not going to learn anything. And that company that sent them, they don't realize it then, but they obviously sent the wrong person if that's the way they think. If you take true ownership of your training and, if you don't completely understand the training, that's your responsibility to make sure you understand it. We can't understand it for you. That's your job. So having ownership of that is what really sets techs apart.
Sure. Yeah, I mean, it's just ownership, period, right? I can't tell you how many times we've had, 20, 30 people training classes, 3 times a month. And we get, a project executive that comes and then he's never on the job site. So then we have installation issue after issue. Here nor there, right? I get that your laborer's hours are more important than the guy that sits in the office all day, right? It costs you more to lose your production force or your workforce than it does to pay a guy that's putting together a submittal or package or something. But anyway, we're approaching 45 minutes, and it's been a pretty good conversation, but I want to bring it back to, what the VRF is, what the basics are, and then kind of in the last 10 minutes here that we're going to be recording, let's talk about the difference between, a VRF system and a mini split, right? The misconception of what a mini split is. So I hear it all the time when a guy installs a 30-head VRF system, VRV system, and they say, I got these mini splits over here, mini splits over there. I was like, no. You've got a VRV system that has a wall mount fan coil. A mini split is a completely different piece of equipment.
Right.
in Viking terms, a mini split is a 4-wire piece of equipment that the outdoor unit powers the indoor unit, and the expansion valve, the EEV that we were talking about earlier, is at the outdoor unit. So with that, there's a whole lot of limitations that come when you have a mini split on the install side, right? So if you think about it, the expansion valve on the outdoor unit. So we still have a condenser, we still have an evaporator, but our expansion device is outside. So that does two things. That severely limits the length of pipe that you can run, and then how you manage that pipe, whether, the still fighting this today, the misconception that, like, oh, you never have to insulate your liquid line. Okay, well, on a mini split, it's not exactly a liquid line, right? Because the expansion device is outside, right? So we're already at a low pressure state when we leave the outdoor unit to go to the indoor evaporator. So that's, to me, that's the major difference between a VRF system and a mini split. Now, other manufacturers treat it differently, but mini splits in general are that way.
Yeah, I would agree completely. There's, how each brand controls their indoor unit on a mini split may slightly differ, but for the most part, it a lot of times it looks at your discharge. I'll give it 1 second. It looks at your discharge compressor temperature, and it looks at approach. So I oftentimes...
Well, back up. You used a big word that we might need to explain there. Approach.
Oh, yes. Approach is... Do we need to explain that?
Not a bad idea.
Okay.
It might.
Approach is basically like the entering air temp of your outdoor coil, and you subtract that of your saturation temp of the refrigerant. It's basically measured kind of like halfway up the coil. It's kind of the easiest way I can think to describe it.
Right.
There's the best way I can think to describe a mini split. There's little communication going on between the indoor unit and the outdoor unit, surprisingly. I mean, it has a fan, it controls the fan. That's really, for the most part, what it does. The thermistors inside don't do a whole lot as far as control. And that was another thing I had a guy kind of, argue with me about. Some mini splits are driven by the physical coil temperature. And it's like, that's not it at all.
No, it's not.
It's not even close. Those aren't there for that. A mini split is almost like a package unit with the remote DX coil. Like, everything's self-contained, and it's basically its own little. It really, the outdoor unit has little idea what's going on inside. It sees what's going on, what's coming back. It can see some thermistors, some readings, but it doesn't know a whole lot what's going on inside. It bases more of what's going on inside on what it's doing outside, what it sees outside, how what the conditions are outside at that unit. Not particularly outside conditions, but in the respective outdoor unit. So that principle in itself is completely different than VRF. VRF, each indoor unit is calling for its own. So each indoor unit will control its own superheat subcooling based on its own metering device, its own EEV. The outdoor unit sees indoor units calling for cooling, or heating, but it won't base its speed off of what's calling for cooling or heating. It'll look at a target condensing or target saturation temperature, not a physical coil temperature, like I got into an argument with one gentleman about. Coil temp, I guess, is something that we might need to talk about in the future. Is when they say coil temp, it's not physically what your coil is per se. It's your system target evaporation.
Yeah, that's definitely something we could talk more on in a future episode of, that word target. what does that mean, right? What is target? Well, a target is exactly what it sounds like. It's a target. The great thing about any of this inverter-driven technology or anything that has basically a PCB in it, right? You can set targets, and those targets are basically the roadmap of how the system thinks it should perform. Back to the sensors on the coils, right? So on a Daikin mini split, like the main function of the evaporator temperature sensor is for ice up protection or freeze over protection. So that it doesn't freeze, right? It's like the indoor unit, if it's a block of ice, then it doesn't work, right? So again, we're expanding our refrigerant at the outdoor section, and we're kind of just hoping and praying that indoor unit has airflow so that it can pick up or add heat to that air. And that's 100% different than what you were saying about VRF and where we're using the indoor coil temperature sensors to basically make some logic changes on the outdoor unit of where the compressor is going to be at, how many pulses on our expansion valve we're going to be open. Do we need to open the expansion valve more? Do we need to close it? Yeah, that's all good information, and we can chalk that up for the notes of a future episode for sure, and really drill down into, control sequences. And I think that would help people out a lot with learning VRF, to know that there's a lot going on behind the scenes, right? Go ahead.
Yeah, I agree. I feel like in the most basic sense, let's say you have 10 indoor units in a VRF system calling for cooling, or let's say there's 10 total and all of them are calling for cooling. Your outdoor unit is going to drive to a certain target evaporation temperature. So the pressures are, for the most part, irrelevant. It doesn't, especially your head pressure and cooling, it doesn't really look at that. If there's only one indoor unit calling, it won't have to work too hard. It won't have to pump fast at all to maintain that one. But all of a sudden, if you have all 10 loaded up, it's going to have to drive that compressor faster and faster to bring down that saturation temperature to satisfy all those spaces. And that's essentially kind of what separates that in a mini split, or really unitary for that matter. Unitary equipment, it has no clue. It just turns on.
Right.
With VRF,
like we were talking about earlier.
It's smart enough to know, I've got this office and this office turned on. I need to go faster. Like, if not, my saturation temperature is going to climb. My suction pressure is going to start climbing. Like, I need to kick it up some speed.
Right. So there's layers on top of that, right? Like, so the deviation of set point versus room temperature, right? Like, if we're 1 degree from set point, we're still going to have some thermal action, but we're not going to have the same expansion valve action that we would if we were 10 degrees from set point, right? So there's a lot of layers to this VRF stuff, and we've just cracked the nutshell.
Oh, we cracked it. Yeah, we just pulled it out of the box. We haven't even cracked it yet.
Yeah, we unwrapped it, and we will crack it in a future episode. But yeah, there's lots of layers on top of it. But what I think we wanted to really drill down on today is just kind of some quick component things, some basics, some fundamentals, and really just it's not much different than a regular air conditioning system, except there's more specialties to it.
Right. It's not that scary.
It's not scary. It's not scary, guys. We've got the two groups, right? Everything Daikin and VRF via VRV Tech Talk, and they're great resources, and I can't explain how happy it makes me that those two groups are so well behaved. First and foremost is like, there's a lot of HVAC groups out there, and out of the 5 or so that I look at, those two are absolutely the best. We got good questions coming in left and right. We've got great moderating staff, and they're really an asset for anybody that wants to be part of the VRF world.
Yeah, there's some really good groups out there, and I'll take that back a little bit. I think a lot of groups start off with some really good intentions, but with how busy they've gotten and how many people there are, it's hard to moderate them. I'm not going to say these groups, you're not going to find any good content. A lot of it is because of how big they've become and how many people post. It's hard to moderate that, and it's hard to like really develop a good culture there. Whereas the two groups Donald mentioned, and it's night and day. You know, there's still a fair amount of trolling that lines up with VRF, but it's surprising actually how well. I've even heard back when I was at Mitsubishi, there was a guy that said, there's nothing against Mitsubishi, and really nothing against any brand, because tech support takes time. I mean, those guys, that's probably one of the hardest jobs, phone tech support in the HVAC industry. So it's not that any brand is better or worse as far as answering their phones, but there's guys that would say they could post something on the VRF Tech Talk group, and they may not have 100% the correct answer, but they'll definitely have a direction to look at. And many times they will get a right answer.
Within minutes, right? Like,
yeah, it's so quick. You know, yeah, you could call it tech support, but it's one of those things like these guys are so helpful, they're so resourceful, and they're not just quick to throw out some ridiculous answer that I've seen on some groups. They just kind of want to flex. You know, these guys, you know, if they don't know, they're not gonna waste your time by saying, did you check the canoodling valve or some
right.
bogus
change
nonsense.
The TXV.
Yeah, change the TXV. You don't have to filter through that nonsense. If they don't know, they don't know. They're not going to post. So if you ask a question, these guys know. They're like, oh, they know, and they're going to see that. They're going to they'll light up a little bit, and they'll post. So anything, for the most part, any comment that someone says to a post, they're asking for help. It's pretty well spot on, or it'll get you in the right direction at least.
Yeah, I would agree. It's within minutes most of the time that somebody's got something, right? And we have such a great admin and moderator staff that, like, a lot of us been doing this for more than 5 years, and trust that we've probably seen a lot of the scenarios that are posted on a daily basis that might be throwing somebody for a loop. So there's definitely somebody out there that's seen it. Me, I'm a little spoiled. I'm in California, so I don't really have to deal with that cold, except for like it's almost 40 degrees outside right now. So, oof.
Oh wow.
There's snow on our mountains. But yeah, definitely check out VRF Tech Talk group on Facebook. We have just over 3,000 members, and for the most part, it's a pretty active group with troubleshooting and tech support for basically all of the brands out there.
Yeah, I agree.
So that was that's the first episode.
Yeah, sounds good. I think we covered a lot of good stuff.
I think we did.
Stayed on topic for the most part, but yeah, it's good.
We'll get some more of our group in here the next time, and hopefully we'll get a little bit more in depth on inverter technology and what really is a variable speed compressor, and how our system's controlled versus somebody else's systems, and really dive into the difference between residential inverter versus VRF for a 14-story building.
Yeah, definitely.
But yeah. So, all right, Steve, thank you for coming on.
No worries. Thank you.
See ya.
Take care.